Good morning and good afternoon, and welcome to this session between Snowflake and Anblix. I'm really pleased to have Abhishek join us, who's their Chief Data Architect based in the US. And what I really wanted to do today is share with you a little bit about Snowflake, but more importantly, how many customers have been getting value from the combination of Anblix as well as Snowflake in terms of modernizing their existing Hadoop environments. And in the process, not only reducing costs, but actually getting far more agility in the ability to create new data pipelines, and most importantly, scale to provide data to the end consumers. So if we could go on to the next slide, what I'd like to do is briefly walk you through our agenda. I won't spend more than 5 minutes walking you through Snowflake and how we've evolved as a company over the last few years. And then I'm going to hand things over to Abhishek, who's really going to talk about, some of the reasons where customers may be looking to modernize their Hadoop environments. They'll also talk about some specific IP that exists that Amblix has developed by working with a number of customers through this process that make it a lot easier. Finally, to talk about a migration strategy, because it would be too simplistic and disingenuous if we said it's a one size fits all. So I'm sure Abhishek is going to cover some common patterns where we see a lot of low hanging fruit in going down this path, and also the best practices, what you should do and what you shouldn't do when looking at a migration. And then finally, we'll end things up with some key takeaways as well as a Q&A session. So without further ado, what I'd like to do is give you a bit of a, next slide please, updated vision on Snowflake. So Snowflake's been around for 8 years, and many of the organizations out there will know us as a data warehouse. However, over the last couple of years, we've really been evolving our offering to now position ourselves as a data cloud. And it's just not marketing. It's actually a lot of innovation that has gone on behind the scenes. So when we look at a data cloud, I think there's really three key aspects of a data cloud that we believe is going to be critical for organizations to be agile and effective moving forward. The first thing is we really need to break down the silos that data is in. And if you look at the challenge of data silos, this is only exacerbated over the last couple of years, because previously you used to have all your data trapped in silos on premise in your data center. Came along the hyperscalers, and data became trapped in these infrastructure clouds. And with the rise of SaaS, we see incredibly valuable data now residing in Salesforce, in Adobe Marketing Cloud, in your success factors. So we really believe there's an amazing opportunity to break down these silos and bring all these different data types, be it data within your organization, data with organizations that you have to transact with as part of day-to-day business. So if you're a bank and you're in the cards business, you will on an ongoing basis be exchanging data with the likes of Visa, American Express. If you're in production or manufacturing, you'll be exchanging data with your supply chain on an ongoing basis. That's second party data. And then finally, given the situation that we're in with COVID and how rapidly the world is changing, there's also a need for people within organizations to access third-party data. And this is data from the likes of S&P Global, FactSet, Refinitiv, and hundreds of other third-party data providers out there that provide valuable insight that allow us to make better decisions on a day-to-day basis. Now, it's not about just providing seamless access to all these types of data. There's an inherent need to govern it and protect the privacy of our users and our customers, and that's another key facet of Snowflake. And then the final thing is, and I think this is where we've seen many data lakes tend to fall down, it's so hard to action the data because of the ability to access it through an organization's choice of tooling, be it a visualization tool, some sort of AI ML notebook or auto ML tool, or traditional batch reporting. So our mission at Snowflake is to make all types of data accessible, to make it easier to govern it, and finally to make it extremely actionable. And if you go on to the next slide, I'll tell you how we do this. We do this by firstly extrapolating a lot of the complexity away from the customer. So the most important thing about Snowflake to take away, it's a SaaS platform. You don't need to individually procure infrastructure elements from the public cloud. You don't need to configure dozens and dozens of services. Snowflake supports these 6 key workloads literally out of the box with almost zero maintenance. So there's no need to vacuum, to index, to partition your data. You're simply loading the data into the system, and then you can do things such as data engineering. So many organizations have gone down the path of using MPP frameworks such as Spark, which require you to learn completely new open source languages. It's hard to maintain, it's hard to tune. More and more Snowflake customers are using SQL to do many of the basic manipulations of their data to get it into a format that's nice and queryable and accessible. Because Snowflake natively supports structured and semi-structured data, and we've announced that we're looking to support unstructured data, more and more customers are looking to use Snowflake as their primary data lake, because with almost no transformation, you can load your semi-structured data into Snowflake, XML, JSON, ORC, and make it instantly queryable. Our pedigree as an organization is data warehousing, and this is a space that we continue to innovate with and provide world-class performance on our platform. And the final 3 workloads are the most exciting, where we see many customers start to do data science on Snowflake because it makes it so much easier to get access to the data that these models need to be able to predict their results and generate scores. Organizations are also looking to build applications on top of Snowflake. And the final use case is really where people are using Snowflake as both a platform to share data within their organization, but also to consume data from our external data marketplace, which has over 100 providers today. So these are the key benefits we see from Snowflake, completely cloud agnostic, your choice of AWS, Azure, or GCP, run as a SaaS service, and you get instant access to execute these 6 workloads on the Snowflake platform. Next slide, Abhishek. And the real secret sauce of why Snowflake can do this is really 3 layers. The first is the fact that Snowflake has centralized the storage. So unlike other offerings where you may have silos of data everywhere, Snowflake is allowing organizations to centralize all their data in a simple central location without any duplication of that. And we've completely separated our storage from our compute layer, which provides a lot of cost efficiencies, but also a lot of flexibility in the ability to instantly scale up and down. And this is quite different from other offerings where it can take minutes, if not hours, to scale up your compute capacity. With Snowflake, it's nearly instantaneous. And this really is quite important, as it really ensures that your users at no time face contention. If you need to run an ELT job in parallel to a streaming job, in parallel to supporting 50 or 60 dashboard users, in parallel to executing a data science model, all of that can happen because we can spin up a near infinite number of clusters in real time and have all these multiple clusters accessing this same centralized storage layer. And as I mentioned before, it's really important that all the data is governed and secure. And this is really where our metadata layer comes in, or our cloud services layer. And this is where we're effectively the brains of the platform. We take care of everything from security and governance, encryption, management of the metadata. We also enable our data sharing through this cloud service layer. So these 3 layers and our architecture is really what differentiates us from other offerings on the market, and it really allows us to achieve our vision of being a data cloud. Next slide, Abhishek. So finally, if I needed to wrap up the 4 reasons that you would look at in terms of adopting Snowflake as a data cloud for your organization, it's really the concept of having only one singular platform, only one copy of the data, yet supporting all these various different workloads. The fact that we're a SaaS service means there's almost near zero maintenance, and it really frees up your teams to focus on getting activity or insight from the data rather than managing the data. Naturally, we wouldn't be a successful company if we couldn't guarantee that all the data was secured, encrypted, and governed and controlled. And finally, I think many organizations see value in Snowflake because we can almost infinitely scale. It really alleviates any of the requirements around capacity management. It also allows many of our customers to start small, and as their business grows, so does their engagement or the utilization of Snowflake. So it's very much a pay-as-you-go model. So these are the 4 key takeaways that I would invite you to remember when it comes to Snowflake. Finally, a little bit about the company. We recently listed on the New York Stock Exchange. We have the privilege of being the largest and most successful software IPO to date on the New York Stock Exchange, and we have a capitalization of around about $80 billion. Forbes used to run the Cloud 100 list. When we listed on the stock exchange, we were no longer a private company, so we graduated. But our exit point was we were actually ranked #1 by Forbes on that 2020 list. We have around about 3,500 customers. This slide is slightly outdated, but the thing that we're really most proud of in relation to our customer base is the fact that we have a net promoter score of 71, which is magnitudes above any of our competition in the marketplace. So we really, really are very passionate about the customer service and the value that you're getting from our solution. And finally, we work within a very strong ecosystem of SaaS providers such as Salesforce, as well as the hypercloud providers, AWS, GCP, and Microsoft. So without further ado, what I'm going to do is hand things over to Abhishek, who's going to walk you through the topic of today's session, which is why would you migrate Hadoop to Snowflake? Over to you, Abhishek.
Perfect. Yeah. Thank you, Jeff, and Snowflake, for being such a wonderful partner. It was a great introduction, Jeff. Thanks a lot. And thank you, everyone, for taking time from your busy schedule to attend this webinar. I know nowadays, everyone is super busy with all the things going on. And brief introduction, my name is Abhishek Kunduru. My role is Chief Data Architect at Amblix. And Amblix is a IT services company and very, very well specialized in cloud and data space. Okay? In today's webinar, we are going to cover 3 main topics. Why migrate from Hadoop to Snowflake? And next thing is how to accelerate the migration, leveraging the Amblix H2S tool, which is Hadoop to Snowflake tool, and a live demo of it. And then the third section is what is the underlying architecture of the tool and the best practices to do the migration. So in a nutshell, why, how, and what is what we are going to cover in the next 30 minutes or so. Like me personally, before embracing the cloud technologies, I was an Hadoop developer for majority of the last 10 years. And building Hive and Impala warehouses, writing MapReduce and Spark jobs, etc. Right? With the experience of implementing, multiple large-scale Hadoop implementations, I can say it is complex, costly, and risk-prone. Broadly, its challenges can be categorized into 3 groups, as you can see on the slide. One is the reliability and performance. There is no proper schema enforcement or schema evolution. Since most of the implementations in Hadoop use Parquet or Avro, more often than not, you would end up with inconsistent schemas. And most of you that work in Hadoop already know that there are no rollbacks. You would need to manually salvage corrupt data, which all of you know is a painstaking process. The second thing is the flexibility. Once Hadoop cluster is created, it is set in stone, especially in on-prem environments. So if you want to scale up or scale out, it has a very long procurement cycle, anywhere from weeks to months. And because of that, it is very unresponsive to business needs. And then the third area is the productivity. It is very complex and expensive to maintain. And upgrades and maintenance cause very long cycles, some taking over in a year. I still remember in one of the large enterprises I worked, like moving from one version to another, like upgrading, literally took 7 months for us to upgrade all the environments, dev until production. So given all these challenges, Snowflake Data Cloud platform is designed to address pretty much all the three challenges: reliability and performance, flexibility and productivity. So mainly it eradicates all the complexities you face with a typical big data platform. And as Jeff already touched, one of my favorite features in the entire Snowflake data platform ecosystem is the near zero maintenance. It self-heals, auto partitions, auto clusters, auto caches, so that you can focus on deriving the valuable business insights rather than spending day in, day out managing the platform from the infrastructure standpoint. And scaling up or down, or most importantly, in or out, is a single click away and just takes few seconds with Snowflake. And one of the most powerful feature that's only available, as far as I know, only with Snowflake. No other data platforms or data warehouses support is a data sharing. So because of that powerful feature, you can avoid writing a lot of ETL/ELT routines to extract the data to FTP or SFTP into your partners or your vendors, SFTP location, and then share it with them. Instead of that, Snowflake allows you to do a single click data sharing, which is a very powerful feature in my opinion. So because of these challenges and the benefits of migrating to Snowflake, there are a lot of enterprises are moving. We at Amblix have done quite a few migrations. And to facilitate or to accelerate that migration for mid to large, even for small enterprises, Amblix has developed a very intuitive push button migration tool called H2S, and mainly to accelerate your migration with up to 40% cost and 60% time savings. I'm going to demo the tool in a bit and show it in action. But before that, I would like to spend a couple minutes talking about its main features or key features. H2S offers a free self-service analyzer to analyze your on-prem or Cloud Hadoop environment and gives a very detailed pre-migration report. And this is a free self-service tool that we offer to our prospects and clients. And the second thing is the tool allows you to either migrate schema only or both schema and data migration, along with supporting incremental and full runs. And most importantly, it has robust validations built in to perform source to target validations so that data is accurately migrated from source to target. And going to the demo, I'm going to show the self-service tool in a bit. Some of the main features in the demo is I'm going to showcase is the analyzer to analyze your data, and then doing a new migration and also restarting an already migrated data set, and then monitoring the migration in progress and seeing the summary of the migration results, and most importantly, reviewing the migrated data in Snowflake. I'm going to do all of that. Yeah. So without ado, this is how the self-service analyzer UI looks like. As I said, like it's a self-service. On the left side, you see the 4 main features: analyzer, start new, restart, and summary. Analyzer is a free feature that we offer to our prospects and clients. And what it does is it allows you to analyze your existing Hadoop environment by accepting few key parameters. One is your existing Hadoop warehouse URL, which is Hive Metastore URL. So, and then the second is the Hive JDBC URL here. And then the third is if you have any stored procedures that you have written in your Hadoop environment, you can give the location of the stored procedures. It could be one or more, comma separated. And what the tool does is it scans all the stored procedures and then creates a migration report saying, which of the stored procedures can be auto-migrated and which would need manual intervention. Yeah. And one of the nice features that we have built is we have also enabled the tool to support Kerberos authentication in case if your Hadoop environment is Kerberized. And for Kerberized environments, you would need to key in two more input parameters. One is a name node principal, and then the other one is the location of the key tag path on the server where you're running the H2S tool. Yeah? So once these minimal parameters are given, you can click the analyze, and what it does is it takes few seconds, 2 minutes, based on the size of your Hadoop environment, and then generates a very detailed report. In our case, this is a relatively small environment, so it took only maybe 5 to 10 seconds. But if you have a massive Hadoop platform, it may take several minutes for it to create the migration report. As you can see, this is the URL, Hadoop environment that I just analyzed. So this is the detailed report that it generates. As you can see, one is an overview of the assessment report, where it gives you the total objects it found as part of the scan. And one of the key metrics it gives is how much of your objects can be auto-migrated with the tool, and how many would need manual intervention, right? Manual migration. And then it also gives a size of your data lake. In our case, it's a relatively small Hadoop environment. This is a demo environment we have set up. But in case of large enterprises, this could be TB to petabytes. And then it also gives a very neat summary of how many databases were detected in the Hadoop environment and how many tables were there in those databases, and the number of views, number of user-defined functions, whether it be Hive or Impala, and then the total number of stored procedures that it has detected, and also all the different file formats that it has detected. As you guys know, most of the Hadoop environments use one or more of these formats, most importantly Parquet. A lot of Hadoop environments use Parquet, and some use Avro, and some use ORC, and then CSV. Okay? And these are all the databases that we have detected. And in each database, how many objects were detected and how many can be auto-migrated through this accelerator, and how many would need some manual intervention. For example, in this database called nested JSON, we detected 6 objects. Objects could be tables or views or UDFs or stored procedures. And all six could be migrated. While as in default database, we have detected 15 objects, out of which 12 can be auto-migrated and 3 would need some manual intervention. Yeah? And these are all the tables that we have seen, we have detected. And then green check marks means it's auto-migratable. And one of the neat features of this analyzer is if you click on any of the tables, it also shows more details about those tables. For example, in this default database, we have detected a table called partitions, and the partitions has 2 columns that are partition columns. Level 1 is state and level 2 is department. And these are all the columns in that partitions table: ID, name, age, salary, state, and department. Yeah? And one of the key things it also tells is whether it's a main age table or an external table, because most of the developers that work on Hadoop would know that there are 2 types of tables that an Hadoop warehouse could have. Main age table, which is internally managed by Hive/Impala. One is an external table, which is an external file, which can be read through Hive/Impala compute. Okay. And in this environment, we also detected these 3 views. And tool also gives you the definition of that view and whether it's migratable or not as well. Yeah? And we have also detected 3 user-defined functions. So our tool, as it stands today, doesn't support auto-migrating user-defined functions. This would need some manual professional services work or internal FTE work. So we are planning to start supporting this feature as soon as Snowflake releases Snowpark feature. Snowflake is planning to release a Snowpark, very powerful feature, which natively allows Java and Python and a couple other languages to be run natively on Snowflake. So, and then these are all the stored procedures that we have identified. And some, for simple to medium complex stored procedures can be auto migrated. And for stored procedures that are fairly complex with a lot of business logic going on, it would need some intervention. Okay? So this is how the analyzer report looks like. And once you're happy with your analysis report and the auto conversion percentage, so you would start with the new migration. This is a start new migration. So these three are the services that are offered by, I mean, these are not the free services. This would, Amblix can work with you to unlock these features for you and for you to either use it by yourself, or we could help you with doing this new migration, restarting a migration and seeing the summary results. Just to save time in the demo, I've pre-populated all of these fields in a different tab. This is the tab. In the start migration, there are mainly four things that like the end user would need to key in. One is the source details, which is your Hadoop environment. Again, the metastore URL, in this case, it's the 233. And then HDFS path, where your data is located. And then we would need a mount path. We would automatically do the mounting, but we just need a mount path on your name node or edge node in one of the nodes. And then your Hive URL, JDBC URL. This is basically your source Hadoop environment. And then if you are an AWS, if you use AWS services, we would need your AWS S3 bucket details. We would use your S3 as a intermediate stage before we iterate or we populate the Snowflake environment. That's why we would need access to your S3 bucket URL, and then its access ID and the secret access key. And then most importantly, your target Snowflake details. Your Snowflake username, Snowflake password, your warehouse that you would like to leverage to do the migration, the connection URL, the role, or whether it's an account admin or sysadmin or public, and then do you want to enable the clusters or not? Yeah? The default is true. And one of the nice features that the tool supports is this exclude DB. So exclude DB means when you are doing the migration, you could use this opportunity to clean up all your test staging and all the dev tables. So to do that, you could exclude like, for example, any database that contains test, right? Or within a specific database, any table that contains stage or things like that. So this would minimize the data that would need to be copied, and most importantly, it would also avoid copying all the unwanted tables to make your target Snowflake environment very clean and to have only the tables that you really want. Yeah. And other neat feature that you see at the bottom here is if you don't want to do everything, I mean, like exporting the schema, I mean, migrating the schema from your Hadoop environment to Snowflake and along with the data and stuff like that. If you only want to export your schema, but not the data, you can, tool allows you to do. You just need to do this and this. And then what it does is it exports the schema out of your Hadoop environment and then imports it into your Snowflake environment, right? So you can pick and choose what you want to do. And very neat feature is before you do the migration, if you would like to do some sampling, meaning if you want to copy, let's say 10% of the data, and then see how it looks, right? The tool allows you. You just need to click the sampling and then key in whatever percentage you would like to migrate. Yeah? So a couple of our customers have asked for it. They're using it. It's a very powerful and neat feature for you to sample the data before you do the actual migration. Yeah? So once you enter the source details, the staging details, and the destination details, you just click the migrate button. And what it does is behind the scenes, it starts an asynchronous job. It's an Airflow job. I'm gonna walk you through the architecture in a bit, but basically what it does is it kickstarts an Airflow job. I'll show you how it looks. This is how it looks. These are all the steps that are involved in here: exporting the schema, exporting the data out of your Hadoop environment, importing the schema into Snowflake environment, importing the data into Snowflake, and capturing all the migration results, and most importantly, doing the validation to ensure that the entire data is copied properly. Right? So all these steps get executed. Given this is an asynchronous job, you don't need to wait. You kickstarted the job. You can, go to some other screen and then come back and then track the progress, right? So based on the size of your Hadoop environment, it could take anywhere from minutes to hours for it to complete the migration. Yeah? And another powerful feature that we offer is the restart migration. So for already migrated environments, if you want to restart the migration, you could use this thing. So as you can see, everything is auto-populated here. So already previously run migrations. It will only show the migrations that have already completed. Because of that, you're not seeing the active migration that is going on, which is a 233 IP, right? So this is one of a very neat feature some of our customers have asked. This would help you to do incremental loads seamlessly with very limited effort. So if you have, let's say, finished your one-time migration, and let's say if you have some additional data accumulated in your Hadoop environment which you want to bring into Snowflake, so you could use this restart migration. Okay. So that's a restart feature. And then the last but not least is a summary. So summary, as you can see here, there is one job that is in progress. You can always track it. You don't need to remember this URL when you started the migration. You can always come to summary and it will show which migrations are in progress and what have been already completed. So for the job that is in progress, you can always track it, which will take you to this URL. And then for the jobs that have run in the past, you can open it and then see the detailed report of all the databases that were migrated, its sizes, as well as all the tables within each of those databases that have been migrated. And most importantly, it will also tell whether the migration was successful or if there is any error. Right? For example, if you look at this table Parquet details, so we have noticed one file, or actually let me take this partitions, it will give you a good example. So in Hadoop environment, we have identified 4 files on HDFS to migrate. We are able to successfully migrate all those 4 files, and it has around 12 rows. This is a very small table. And both in the source, which is Hadoop environment, and in the target, we found 12 and 12. And we ran this migration script just to make sure that everything is migrated correctly, this one here. So, and we have made sure, after all the validations are complete, we have put this green tick mark. Yeah? And for example, in this case, for tweets table, so we have noticed a discrepancy in the source and target rows. So we have marked it as validation failed. Yeah? So just to showcase, we have created a demo table where we intentionally let it fail so that to showcase that feature as well. Yeah? And then these are all the 3 views that have been migrated. Yeah? So it gives a very neat summary of all the things that were moved from source to target. Yeah? So once the migration is complete, so you can go into your target Snowflake environment and then start seeing the tables and all the objects that were migrated there. Okay? So in this example, I'll show you. Okay, so if you see, these are all the databases that we have migrated: default, larger files, nested JSONs. So if we go to default, so these are all the files that were migrated. Like for example, tweets. This is a table that we saw some discrepancy, right? And this is a partitions table where I've said there are 12 rows. Right? So these are all the tables that were migrated with the help of our tool. Yeah? And you can always go and for the people that are already comfortable and aware of the Snowflake environments, you can go into the worksheets and then query those tables too, or preview them. And do all sorts of stuff. Okay, so these are all the things. Just to let you know, everything once the migration is complete, you will be able to see all the databases and tables and views and stuff like that in this view. Okay? And coming back to the presentation again, let me put in the presentation mode. So for people that are curious about the architecture, like how we have built the tool, I mean, how does what does the architecture look like? As you can see it in this diagram, it is a 3-tier architecture with front end built in React and back end processes built in Java, and all the processes orchestrated by Airflow and migration metrics stored in Postgres. And the most important thing is we have modularized this entire architecture into 4 pieces: the schema export, schema import, data export, and data import. And this modularization allows us to run only the required modules. So for example, if you want to migrate only the schema from the Hadoop environment to Snowflake environment, but not the data, right? So we only need to run the schema export and schema import. Right? And if you also want to do the data, then we'll do data export and data import. So schema export, as the name says, it connects to the source Hive metastore, the metastore details that we have given in the self-service UI. And it extracts the Hive schema out of it and translates it into the Snowflake DDL, which is Snow DDL. And schema import connects to the destination Snowflake environment and executes a Snow DDL to create the schema. And by the way, this H2S DDL translator is fairly sophisticated. It is responsible for in the schema export box, by the way. That's one of the key brains of this architecture, and it is that H2S DDL translator is responsible for converting all the Hive objects into Snowflake objects. Okay. And schema exports connects to the destination Snowflake environment and executes the Snowflake DDL to create the schema. And data export as well connects to the Hive metastore to get to know the HDFS data locations and move them to the AWS S3 and or Azure ADLS Gen 2 staging area based on your staging location. And if you see there, we handle the managed tables and external tables slightly different. For managed tables, the tool copies the entire HDFS directory in one shot, while as for the external tables, it does table by table, since each table could be at a different location. Yeah? And data import leverages Snowflake's very powerful stages feature to copy data from either S3 or ADLS Gen 2 bucket into your final tables. And for incremental load, which is a restart migration utility, it leverages a Snow pipe. And at every step of the migration, detailed metrics are returned to Postgres here. And those migration results is what is shown on the UI in the summary page. And I just showcased all these 4 main features: analyzer, new or restart migration, monitor, and validation results. And as I said before, this entire UI is built on React. And everything is orchestrated by Airflow here. So coming to the best practices, I know, the architects and the tech guys on the call, would be very much interested in this. First I'll go through the do's and then we'll go through the don'ts. Mainly to migrate medium to large data sets, always use Snowflake stages, also known as copy to feature in Snowflake. For the initial and full loads, because stages are very powerful feature. It can support iterating like terabytes to petabytes of data seamlessly. Okay? And use Snowpipe for incremental loads. And then this is one of the key things. If possible, when you are migrating, also build integration with catalogs. If you're an AWS shop, you may want to use Glue, or if you're in Azure, like use Data Catalog, or one of the industry leaders like Alation or Colibra or Talent Data Catalog, right? So if when you're migrating, use this opportunity to build integration with it so that you register all your data sets in a very easy to use data catalog, so that it becomes easy for your data scientist or a data analyst or a data steward to locate your data sets in Snowflake and then leverage them properly. Yeah? And use file-based transfers instead of row level. I know I've seen a lot of people when they migrate, they use JDBC or row level transfers. It would be very slow and error prone, while as doing a file-based transfers, meaning moving a file from your source HDFS location to a staging and then iterating would be much more robust and fast. And most importantly, build robust validations or reconciliations to ensure that data is copied properly. And migrating stages. I mean, this is a debatable. I've seen both sides of the equation where some companies prefer lift and shift first to go to market fast with the new environment, with the new Snowflake-based environment. And some companies, they want to go the big bang approach where they not only want to lift and shift to the more modern cloud native technology like Snowflake, but at the same time, they also want to optimize the data model. So it depends, but generally lift and shift seems to be an approach a lot of companies take to go to market fast. And when it comes to don'ts, don't use JDBC to copy large volumes of data. It will take forever and then it is more error prone. And avoid using Snowpipe for initial or full loads. Instead use stages or copy to. And avoid migrating stage, test broken objects as much as possible. As I said before, use this opportunity to do the cleanup. You can avoid like moving all the unwanted tables or views or databases and stuff like that. Yeah. And a typical engagement process, I'll quickly go through it. So it's almost like an 8-step process. I mean, pretty much most of the companies would that are planning to migrate would go through these 8 steps. The very first thing is analyzing. You could use a tool like HUS Self-Service Analyzer, or you could do it manually. Manually doing it would take a lot of time. The second is setting up a Snowflake account with proper roles, proper users, proper accounts, proper warehouses, as Jeff briefly touched in the beginning. Setting up multiple warehouses to handle the different workloads like reporting workload and data science workloads, ELT workloads, and stuff like that, right? So setting up, strategizing that with the help of either a Snowflake resident solution architect or a professional services architect like Amblix Snowflake Architect, and setting up this environment. And migrating the schema, you could leverage H2S tool for it. When I say schema, all the objects. And then migrating the data from, you can again leverage a tool like H2S. And then data ingestion, you need to repoint your ETL/ELT routines to write to Snowflake instead of your legacy environment, which is HDFS or Hive or Impala. And then you also need to repoint your APIs and reporting layer and analytical tools to Snowflake instead of the legacy environment. And then perform the validations. Generally, we recommend doing a parallel runs at least for a month or so until all the validations are complete. And then once all the validations are complete, decommission Hadoop and inform all your users to start using Snowflake environment. Yeah. And key takeaways, coming to the H2S accelerator, it's a push button solution, push button and self-service solution to migrate your Hive, Impala, and HDFS to Snowflake. And it supports both schema only as well as schema and data migration. And most importantly, save significant amount of time and costs. And benefits of migrating from Hadoop to Snowflake. It's a near zero maintenance, very powerful feature of Snowflake. It avoids all the headaches with a typical, legacy data warehouses. And you can make better, quicker business decisions instead of spending a lot of time maintaining your Hadoop cluster and stuff like that. You would rather focus on your data and then to derive faster insights from it, and better and faster insights. And you can also reduce the cost of scaling data management and analytics. Over the you would, very soon realize the cost savings, from going to a pay-as-you-go environment like Snowflake. So that's pretty much it from my side. So feel free to post the questions. I'd be more than happy to answer them.
Thank you so much, Jeff. Thank you, Abhishek. Team, we have Q&A window. You can see a Q&A button at the bottom of your Zoom webinar. Please use that to post your questions, and also feel free to use chat box there to ask your questions. Yeah, so I've kept the window open for question and answers as well as chat session. So we have one question, Abhishek, saying that there is a current Oozie workflows that are stored in Oozie Hadoop database are not migrated by H2S. How do I deal with, say, 300x Oozie workflows that are in my current 600 TB Cloudera cluster contains?
Okay, so so most of the time Oozie workflows could have some custom orchestration built into it, and most importantly custom scripts built into it too. It would need to be manually migrated, because it is not part of the database objects or the HDFS data objects that the tool migrates automatically. So it would involve some sort of a manual work, because it's more like a orchestration framework. Yeah.
Okay, cool, thanks. So Jeff, this question is for you. Basically, it says, how is Snowflake as compared to Cloudera's new CDP public cloud offering?
Okay, I think the solutions differ in two ways. So the first way in which they differ is Snowflake is a SaaS offering, so that when you pick Snowflake, you can choose which cloud you choose to deploy on, but you don't need to manage the underlying cloud IaaS as well as the actual software separately. And that's my understanding of how the CDP public cloud offering works. You still need to engage with AWS or with Azure or GCP to get the infrastructure to deploy the tool on top of it. I think the second big difference is actually the breadth of the offering. Many of our customers that choose Snowflake are doing so not just to use us as a data lake, but really to use us as an enterprise-grade data warehouse, which I think we've had hundreds of successful companies move from existing data warehouses onto Snowflake, but also to use us as a data exchange. So I think the breadth of offering as well as the type of offering is how we differ.
Okay, cool. Thanks, Jeff. So this question is for Abhishek. It's about, does H2S tool support migrating partition tables? If they do, are the partitions replicated in Snowflake?
Yes, absolutely. So it does support partitioning. Moving all the partition tables. I've actually showcased one such tables when doing the demo. The only difference is Snowflake doesn't have a concept of partitioning. Instead, it has this concept of clustering. So because one of the nice features of Snowflake is you don't need to worry about what columns to use for partitioning and etc. It automatically detects based on the data that you're pumping into it. It detects what columns to micro partition by, right? So it does auto partitioning, but our tool also detects the partition keys and then creates clustering based out of that for really large tables.
Okay, got it. Thank you. So Abhishek, the one more question is about Kerberos functionality. It says, what happens during a large H2S data export where Kerberos is being used in the source Cloudera cluster and the Kerberos ticket expires? Does H2S contain ability to regenerate Kerberos ticket on the fly and continue the export job?
If generally the key tab file, if you configure your Kerberos properly, you can set some sort of a timeout, like maybe 8 hours or 6 hours, based on the size of your data. It shouldn't. But if it does expire, we can always leverage the incremental migration feature that H2S offers to migrate only from the point of expiry instead of starting from the beginning again.
Okay, got it. Thank you, Abhishek. There's one more question. Is what about HBase migration?
That's a very good question. Tool currently doesn't scan the H-based databases because of the nature of the underlying data. Currently as of now it doesn't. We will put it in the roadmap and then do some brainstorming to see if these connectors need to be built for migrate.
Okay, sure.
Yes.
Thank you. And the next question is, how does H2S tool handle serialized data?
So it is, one of the neat things is Snowflake automatically understands. If you just give it a serialized data, so it automatically knows how it is serialized, what kind of survey is used for it, and then automatically deserializes and then loads it into its data store. So in other words, it's supported out of the box without we doing anything.
Okay, the one more technical question, Abhishek, is does H2S support reading Cloudera Erasure coded HDFS data in the source cluster?
What was that again, Munwa? Can you repeat that, please?
Yeah, perhaps you can see in the chat window. It is ERASU.
Kudu. Yeah.
How does yeah?
Yes, absolutely. Kudu, right? Yeah. Is that the one? The one before the Q5? Okay. Does HDFS support cloud?
Yes.
HDFS data. Okay. It's actually a good question. This is something I have to get back to you. I don't have an answer, quite honestly, for Q5. Let me. I'll get back to you. Whoever has asked that question. It's a very fantastic question. Yeah.
Good,
but the Q6 is. Q6, the question 6, does HDFS support reading Kudu data? Yes, absolutely. Yeah. We do support reading Kudu and then pushing it to Snowflake. Yes.
Okay. So this is a question for Jeff. Basically, it says, is it possible to do DML operations in Snowflake? Can we do it in place or need to do something like CTAS?
I'll let Abhishek answer that question.
Yeah. Yes. So, at the end of the day, we have to keep one thing in mind that Snowflake is very well designed for OLAP kind of workloads. Right? So it's a data platform with data warehouse being the center of it with everything revolving around, right? So which means it does all the DML operations, but it's meant not to be used as OLTP. It is mainly meant for OLAP cases, analytical cases, rather than transaction processing cases.
Okay. So I'm taking one last question. There are many questions coming in. We will respond it offline actually from the tool. And this one question is: does Snowflake offer ODBC integration for tools like Alteryx and Power BI?
Yeah. So actually. We do above and beyond that. So we have generic ODBC, JDBC drivers, but specifically for the likes of Alteryx and Power BI, our engineering teams are working closely together with Microsoft and Alteryx to do native integrations. So just last month, we announced a native integration with Alteryx where a lot of the push down processing can actually occur within Snowflake to really improve the performance of the citizen data scientists when they use Alteryx. So yes, of course, we do ODBC, but we do above and beyond for quite a number of visualization and data science tools.
Okay, got it. Sure, thanks a lot, Jeff. So what we'll do, can you move to the next slide, Abhishek, the one you have? So basically, I know we are getting a few more questions and we are running out of time. What we'll do is, first of all, apologies, we are not able to answer online, but we are going to get back to you to answer to your question. And also, please feel free to write to us here. We would like to have a free assessment using our H2S analyzer. So this is an offer which we would like to help you install and check it out. Even before doing the migration, you can run the analyzer and see how much of that migration can be automated. That gives you a quick understanding of the size of the migration, and also the best practices outlined by Abhishek can also be followed. Feel free to reach out to us and we will get back to you. And can you go to the next slide, Abhishek? So these are the contacts we have in the slide. Anything related to Snowflake, please do reach out to that particular email ID listed here, as well as on the Analytics side. And again, once again, thank you so much for participating, and we really appreciate your time. And looking forward to talking to you again through our Snowflake. And it's really a wonderful tool, and we are very much happy to be partnered with Snowflake. And thanks once again for all of you for joining the webinar.
Yeah,
Thanks,
thank
everyone.
you. Yeah, bye.